press record. Okay, so new unit, probability. All right. Review really quick. What is the definition of probability? Gauge? Good. The chance or likelihood of an event happening. And how about experimental probability? Then
the probability found through experiment of an event happening.
The probability found through an experiment of an event happening. Nice job. Okay. Where did it go? Here we go. All right. So so today and tomorrow we're going to talk about experimental probability. And experimental probability is just basically, there are situations when you want to predict an event happening, but it would be really hard to find what's called a theoretical probability. We're talking about theoretical probability next, so I know you guys don't quite know what that is yet, but experimental probability is really predicting something based on data that's already been gathered. So it's like you perform an experiment or, experience, you collect the data, and then you use that to predict something else. Does that make sense to everybody? Kind of? Okay. So like, and during ELO, we were talking about football games and like number of points. Yeah, because I'm super familiar with football. That's like totally my wheelhouse right there, you guys. That's my sarcastic face. Okay. So, but the idea was that it might be hard to predict the score based on anything except past scores. And to get past scores, you would just need to collect data. So you might want to predict what a team would score in a 17th game or something like that. And you would base that off of the previous games played. So experimental probability is when experiments have actually been performed and data has been gathered. Okay, so here's an example of a probability chart in front of you. So your top slide. All right, so we've got 2 dice. And we want to know the number of times that each of these combinations have been actually rolled. Okay, so the way to read this is the number of times that I rolled a 1 and a 1 was 2. Okay, so this is that right there. I rolled a 1 and a 2 7 times. Okay, this is die number 1. This is die number 2. And so these are actual results collected. Now, you guys, I didn't actually do this. This is from your textbook, but you can pretend. So we would want to know, let's say we want to know the number of times both dice show the same number. Okay, we had 120 total rolls. And those were the results. So how many times did both the dice show the same number? So we're looking for 1 and 1, 2 and 2, 3 and 3, 4 and 4. How many times did that happen? You guys, circle them. It happened 8 times. Great job. Okay, so they happened 8 times. Now, 8 out of 120. Is there a high probability that I will roll doubles? Not really. No, that's not a very good chance. Okay, 8 out of 120. Let me erase those. Now, what is the chance of both dice showing an even number? What is the chance of both dice showing an even number? So let's circle those events. We're not going to look at any of the 3s, but we'll look at the 2s and the 4s. Okay, how many times did that happen in my set there? How many times did that happen? Okay, so what we're doing is we're adding these numbers, the number of rolls over here. How many times did that happen? Kinsey? 24 times, exactly. So 24 out of 120. What has a better chance? Me rolling doubles or me rolling 2 evens? 2 evens, good. So 24 out of 120. How about this? The next question is, what's the chance of me rolling 1 die at odd and the other even? So 1 die odd and the other even. I don't think you guys added that up that fast, did you? Or is it in your, oh, dang it. I gotta alter those. It's in your notes already? Okay, well then what's the chance? It's 73. Okay. Good job, friends. All right, so I gotta. Well, if you were to add them up, you would have gotten 73. Okay, so here's what I'm gonna show you guys the way to write probability. Who remembers that our fraction bar means out of? That's one of the meanings of the fraction bar. Good. Okay, so when we write probability, it looks like this. The probability would have been 8 out of 120. Now we would always simplify that. I'm not going to, just for the sake of time right now. And that you can see that it's 8 events out of 120, 24 events out of 120, and 73 out of 120. P equals probability. That's all it equals. It's not confusing, right? It's not even algebra. It's just a label. All right, let's do a little activity. You guys are gonna get a box with 8 pennies and 2 dimes. You're gonna find out what the chances are of picking a penny or dime from the box by doing an experiment. Kinsey, I'm in the middle of instructions. Do you need something? Okay. First, one person will pick a coin from the box without looking or feeling, and then you're gonna record which coin you selected on the table, return the coin to the box, and take turns picking the coin for 9 more turns. So you're doing 10 tries, right? Pretty easy peasy. Over here, you're gonna write penny or dime. It's very important you return the coin back to the box, otherwise that changes the probability. And we'll talk about that in a future lesson. We'll talk about that now. All right, so you guys have the chart in front of you, and I will hand out the boxes and the coins. Okay, guys, so let's talk about a result. All right, Alex. Sure. Right, so what would we're gonna talk about it. It would be 0 out of 10, exactly. Okay, I need a group to represent. Who is willing to give me all of their numbers? Kendall. All right, so just read me your results. Okay. Oh, just a second, my pen's not working. Okay, penny, 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 penny. Okay. Awesome. So Kendall's group. What was your chance of picking a penny? Well, we're gonna actually express it. Good job. It wasn't 20%. Your chance of picking a penny, but 80%. We're actually gonna express this as a fraction today, but you're absolutely correct that probability can be expressed as a percentage as well. So fractions, percentages, or decimals. Okay, so 4/5. How about your chances of picking a dime? Okay, let me ask somebody else. What was your chance of picking a dime, Gabby? So if you look up here, Gabby, we're just using these results right now. So I know yours are probably different. Since this is experimental probability, we're all going to have maybe different results. What was the chance of picking a dime? Yeah, good job. And simplify that is 1/5. Good. What coin do you think would be picked on the 11th trial based on our probability? A penny. Good. What would be the chance of picking a nickel? 0 out of 10. Good. 0%. Whoops. Okay. So you know what's interesting, you guys, is that the results that Kendall's group got were exactly the results that I had last year. 8 out of 10 times a penny. I didn't have the exact trials written down, but 8 out of times a penny was picked. 8 out of 10 times, and 2 out of 10 times the dime was picked. What were other people's results with that? Did anybody have like vastly different results? Yeah. What did you guys get, Maddie?
We got picked up 3 dimes, but in fairness, not saying names, but somebody was stealing for the dimes one time.
Oh, you got to throw that trial out then. Okay. Elijah.
Yeah. 4 dimes.
Did you really? Interesting. Okay. 4 dimes and 6 pennies. Alex?
You got the exact same thing. like penny, dime, penny, we had the exact same.
Like even like the lineup of the trials was the same? Well, that's pretty crazy. Wow. Okay. So again, this was experimental probability. So we performed an actual trial and basically counted. All right, let's compare everybody to Sanders' results on page 121 in your textbook. In this experiment, there are two possible outcomes. I need your voices off now. Thank you. There are two possible outcomes, picking a penny or picking a dime. So just a little bit of a probability term there. Outcome is, you know, what can happen when you perform your trial. So Sandra, 9 out of 10 times, picked a penny. So we would say that the chance of picking a penny is 9 out of 10. Can we simplify that, you guys? Okay. 1 out of 10 times, she picked a dime. So her chance of picking a dime was 1 out of 10. So can we say for sure that on the 11th trial, Sandra will pick a penny? Yes or no? No, we can't say that for sure, right? But is there a higher chance of her picking a penny on the 11th trial? Okay, good. Any questions on that? Okay, you guys have an exit ticket. Go ahead and do both of those problems now. I don't want to do that.